By this point, you might be thinking, hey, we're finding critical points. Is there anything like a second derivative test to tell us if they're maximums or minimums like there was in the one variable case? And I am so glad you asked. Let's talk about the second partials test for relative extrema. It's a little bit more lengthy than for the one variable case, but it looks something like this. If the partial derivative of f with respect to x of the point AB equals 0, and the partial derivative of f with respect to y of the point AB also equals 0, what we do is we let d be the value fxx of AB times fyy of AB minus fxy of AB times fyx of AB. So you're going to have to calculate all the partials, and we multiply them and add them together in this weird way. If d is greater than 0, and fxx of AB is greater than 0, then AB is relative minimum. If d is greater than 0 and fxx of AB is less than 0, then AB is a relative maximum. If d is less than 0, then the point AB, FAB, remember FAB is the output, is a saddle point, which looks a little something like this over here. And if d equals 0, we don't get any information. With that in mind, let's take a look at an example. We want to find the relative extrema and saddle points of the function fxy equals x times y minus 1/4 x to the fourth minus 1/4 y to the fourth. So first things first, we need to find the partial derivatives with respect to x and y and set them equal to 0. The partial derivative with respect to x is y minus x to the third. And the partial derivative with respect to y is x minus y to the third. And we set those both equal to 0. And so we get 0 equals y minus x cubed, and 0 equals x minus y cubed. In order to solve for x and y, we can just use some substitution. So here, focusing on this equation, we can rewrite this to be y equals x cubed, and we can substitute that in over here to get 0 equals x minus x cubed. So then 0 equals x minus x to the ninth. And the only things that satisfy this are x equals 0, 1, and negative 1. If x equals 0, then y equals 0. If x equals 1, then y equals 1. And if x equals negative 1, then y equals negative 1. So our three critical points are 0, 0, 1, 1, and negative 1, negative 1. So now we need to calculate that value d. Let's remember what d is. d is fxx of AB times fyy of AB minus fxy of AB times fyx of AB. So let's calculate that. First things first is we need to calculate fxx. So fx is right over here. It's y minus x cubed. The derivative of that with respect to x is minus 3x squared. fxy is the derivative of fx with respect to y is just 1. fyx is equal to fxy always, so it's just 1. And fyy, we have fyy up here. We take the derivative with respect to y. We get minus 3y squared. All right, with that in mind, the value d is minus 3x squared times minus 3y squared minus 1 times 1. Now we can plug in our different points. d of 0, 0 is minus 3 times 0 squared minus 3 times 0 squared minus 1 times 1, which is equal to 0 minus 1 equals minus 1. Now here d is less than 0, and so that tells us that the point at 0, 0 gives us a saddle point. Now let's plug in 1 and 1. So then d equals minus 3 times 1 squared times minus 3 times 1 squared minus 1 times 1. And this is going to be minus 3 times minus 3 minus 1, which is equivalent to 9 minus 1 equals 8. So we have that is bigger than 0. And fxx of 1, 1 equals negative 3 is less than 0. So that tells us that we have a relative maximum. So 1, 1 is a relative maximum. And now the last thing we need to do is plug in minus 1 to both of these. So we have minus 3 times minus 1 squared times minus 3 times minus 1 squared minus 1 times 1. And this is going to give us the same values we had earlier. That's going to give us 8. And fxx of minus 1 equals minus 3 is less than 0. So minus 1 is a relative maximum. All right, let's take a look at one more example. It says a company makes two products whose demand functions are given by x1 equals 200 times p2 minus p1, and x2 equals 500 plus 100 p1 minus 180 p2, where p1 and p2 are the prices per unit, and x1 and x2 are the numbers of units sold. The cost of producing the two products are 50 cents and 75 cents per unit respectively, and what we want to do is find the prices that will yield maximum profit. Let's remember that profit is just revenue minus cost. So let's figure out the revenue function and the cost function and squish that all together. So the cost function here is going to be 0.5 times x1 plus 0.75 times x2, which is equal to 0.5 times 200 times p2 minus p1, and that's just from this function up here, plus 0.75 times, and then x2 is 500 plus 100 p1 minus 180 p2. And this simplifies down to be 375 minus 25 p1 minus 35 p2. So this here is our cost function with respect to price. The revenue function is just x1 times p1 plus x2 times p2. So again, just like with the cost function, we want to get the revenue function in terms of price. So we make our substitutions, and we get p1 times 200 times p2 minus p1 plus p2 times 500 plus 100 p1 minus 180 p2. And then that will simplify down to be minus 200 p1 squared minus 180 p2 squared plus 300 p1 p2 plus 500 p2. And now that we have all that, we can combine revenue and cost together to get our profit function. So our profit function is going to be our revenue function, so minus 200 p1 squared minus 180 p2 squared plus 300 p1 p2 plus 500 p2 minus, and then the cost function, which let's recall that was 375 minus 25 p1 minus 35 p2. Okay, and now if we combine like terms together, what we'll end up with is our profit function p equals minus 200 p1 squared minus 180 p2 squared plus 300 p2 p1 plus 25 p1 plus 535 p2 minus 375. Okay, so it's a long function, but we're going to take a derivative of it, and it's going to make it a lot easier. All right, so we have a function here of two variables, our p1 variable and our p2 variable, and we want to find the relative maximum. So we have to find the partial derivative of p with respect to p1, and that is going to be minus 400 p1 plus 300 p2 plus 25. And we also need to find our partial derivative of p with respect to p2, and that's going to end up being minus 360 p2 plus 300 p1 plus 535. Now with that in mind, we can do like we did in the previous problem and set both of these equal to 0. I don't know what happened there. Set both of these equal to 0 and use substitution to solve for p2 and p1. I won't go through that right now, but suffice it to say what we end up with is that p1 equals $3.14, and P2 equals $4.10. So now what we want to do is use the second partial derivative test to figure out if this is a relative maximum or a relative minimum. All right, so let's recall D is going to be equivalent to P, P1, P1 times P, P2, P2 minus P of P1, P2 times P, P2, P1. So there's a lot of P's going on right now, but let's remind ourselves that this capital P here is the profit function. This subscript P1, P1 means the derivative of the profit function with respect to P1 with respect to P1. So we're taking the second derivative, both derivatives with respect to P1, and similarly for the rest. All right, so this notation looks confusing. Let's not get bogged down in the notation. Let's just do our computation. So P, P1, P1, that means we're going to take the derivative of this P1, of this P, P1 here with respect to P1, and we're going to get minus 400. Okay, similarly, this P, P2, P2, we're going to take the derivative of this guy here with respect to P2. The only thing that stays around is minus 360. Here, P, P1, P2 is the derivative of this guy here with respect to P2. And what we're going to end up with is just 300. And then here, P, P2, P1, which is equal to P, P1, P2, is going to be, again, 300. Now that we have all this written out, you can throw that into your calculator and you'll realize that this is greater than 0. And also, P, P1, P1 is less than 0. Now that's regardless of the values of P1 and P2, because P, P1, P1 is always just negative 400. Okay, so here we have D is greater than 0, and P, P1, P1 is less than 0. So that means that P1 equals 3.14 and P2 equals 4.10, we have a relative maximum. So these are the two prices we should charge to net maximum profit. If you're curious about what the maximum profit is, even though the question didn't ask for it, you can throw these two into the revenue function, and or into the profit function, I should say, and you'll figure out that the profit of 3.14, 4.10 is $761.48.